This is today's number 20 most urgent vulnerability on the Daily Ranked CVE Brief, where we look at what to patch first, ranked by real exploitation signal, CISA KEV, first EPSS, and CVSS. Today's issue is CVE 2026-67325 in GitPython, and the plain English risk is simple. Under the wrong conditions, an option that should have been blocked can be shortened in a way Git still understands, letting dangerous behavior slip past the guard. NVD describes the result as arbitrary command execution. This is not currently listed in CISA's known exploited vulnerabilities catalog, so we are not treating it as confirmed mass exploitation. But an 8.8 CVSS score, command injection, and a meaningful EPSS percentile are enough to make this more than a routine library update. GitPython is a Python library used by applications and automation to interact with Git repositories. CVE 2026-67325 is classified as CVE-78, which means Operating System Command Injection. In human terms, that is when data that should only shape a safe command ends up influencing the command line in a way that can cause the system to run something unintended. The specific flaw here is an incomplete command injection blocklist. The guard was meant to stop unsafe Git options, but it did not account for Git's long option prefix, abbreviation feature. Git can resolve shortened option names into their full option names. So, if the safety check only recognizes the full dangerous option, an abbreviated version may pass the check, while Git later expands it into the dangerous behavior. That gap is the core of this vulnerability. Verdict: this is a high-impact command injection bug that deserves prompt remediation anywhere GitPython is exposed to low-privileged user influence. The two CVSS details that matter most are reachability and impact. First, the vector is network attackable, low complexity, and requires no user interaction, but it does require low privileges. That means this is not scored as a fully unauthenticated internet free-for-all, but it can matter a lot in applications where logged-in users, tenants, CI users, or automation accounts can influence Git operations. Second, the impact is high across confidentiality, integrity, and availability. Command execution in the context of the application process can mean reading sensitive data, modifying files or repositories, or disrupting the service. Scope is unchanged, so the score does not assume a boundary jump, but 8.8 is still serious. CISA KEV status is false for this CVE, which means CISA has not listed it as a known exploited vulnerability, based on the information provided here. That lowers the immediate signal compared with a KEV-listed bug. It does not make the issue safe to ignore. The EPSS percentile is 0.7142, placing it above a large share of vulnerabilities in exploitation likelihood ranking. More importantly, this is a library vulnerability. The risk rarely looks like a user directly attacking GitPython in isolation. It shows up inside developer portals, automation tools, repository management features, build systems, internal platforms, or custom services that rely on GitPython. If those systems accept input from users or integrations and then perform Git actions, the library can become part of the attack surface. That is why the right response is targeted urgency. Find real exposure, then patch quickly. Conceptually, the attack path starts with a place where an attacker has some low-privileged ability to influence a GitPython operation. That could be a feature that works with repositories, references, remotes, Git options, or automation inputs. The exact exposure depends on how the application uses the library. The important part is not a magic packet, it is data flow. If untrusted or semi-trusted input is passed into a Git operation and the application relies on GitPython's unsafe options guard to keep that operation safe, the abbreviation behavior matters. The blocklist can miss the shortened form, while Git itself still resolves that shortened form to a dangerous option. CVSS also tells us no user interaction is required, so the vulnerable workflow does not depend on tricking an administrator to click something. Defenders should map where user-controlled values can reach GitPython calls. To check exposure, start with inventory. Look for GitPython in Python dependency manifests, lock files, software composition analysis results, container images, virtual environments, and build pipelines. NVD describes the affected range as GitPython before 3.1.51, but you should verify exact version guidance against the vendor advisory and your package source before closing the ticket. Then move from version checking to exposure checking. ask which applications actually use GitPython to run Git operations. Which of those applications are reachable by users, API clients, CI jobs, webhooks, or internal integrations? Which code paths pass user-controlled or tenant-controlled values into repository operations or option handling? If a service runs GitPython only in a tightly controlled maintenance job, its urgency may differ from a multi-user web service. Prioritize internet-facing and multi-tenant workflows first. The main remediation is to move affected GitPython deployments off vulnerable versions, following the vendor advisory and your normal testing process. Because this is command injection, do not stop at a version bump. Review whether your application allows users or integrations to provide raw Git options, repository parameters, or other values that shape Git command execution. Prefer allow lists over block lists, wherever your own code validates options. Remove unnecessary flexibility from exposed features. Run services that invoke Git with least privilege, using accounts that cannot read unrelated secrets or modify unrelated files. Keep build workers, repository workers, and application servers segmented where practical. Make sure secrets used by those services are scoped narrowly and rotated if you find signs of suspicious command execution. Finally, rebuild and redeploy containers or virtual environments so the fixed dependency is actually present at runtime. For monitoring, establish what normal GitPython behavior looks like in each service. Normally, the application or worker should spawn expected Git operations against expected repositories with predictable arguments, running as a known service account. Watch for deviations. High-value signals include unexpected child processes launched by the application process, especially shells, interpreters, download utilities, or system administration tools that are not part of normal Git workflows. Look for unusual Git arguments or abbreviated long options in application logs, job metadata, audit trails, or command line telemetry if you collect it. Also, watch for outbound network connections from repository processing hosts that normally only talk to source control, artifact storage, or internal services. File writes outside expected checkout, cache, or workspace directories are another warning sign. Treat these as investigation triggers, not proof by themselves, and correlate with user actions, job submissions, and recent dependency versions. Bottom line, CVE 2026-67325 is a high-severity GitPython command injection issue caused by an incomplete, unsafe options block list that misses Git's long option abbreviation behavior. It is not currently in CISA KEV, but the 8.8 CVSS score, high impact across confidentiality, integrity, and availability, and EPSS percentile, keep it on today's ranked list. Your best next step is to identify where GitPython is used. Confirm whether any deployment is before the fixed version guidance. Prioritize services where low-privileged users can influence Git operations and patch those first. If this helped you decide what matters today, subscribe to the Daily Ranked CVE Brief, What to Patch First, ranked by real exploitation signal every day.